This video has been created in order to present you a cloud appliance, which is a turnkey solution of platform as a service. It has been developed within PSNC in the M2DC project. Cloud appliance is a whole setup that enables easy development, testing and deployment of applications. It includes both hardware and software stacks. The hardware can be fully configurable by customers and consists of microservers and hardware accelerators like GPUs and FPGAs. Such a combination is possible thanks to Rex4 chassis developed by Criswell & Company within the project and result in densely packed hardware. In other words, high performance per small space in server room. In order to facilitate the demonstration, we are visualizing the demonstrated cloud appliance in our monitoring system called BEMOS. The visualization shows the testbed consisting of 4 nodes, you can see them here, and 2 accelerators. Within this demonstration, 3 of them are used. These are the nodes starting with Xeon E. Each of these nodes has a Xeon E 1505 version 6 mobile processor forming Cable Lake. Each of the processor has 4 cores and 8 threads. And this presented here hardware is possible for a configuration of cloud appliance as a product that can be bought by the customer. Just an example, I'm showing now the power usage, the map of power usage on the presented hardware, and right now one of the server is fully occupied and consumes 50 watts. On the other hand, as a software stack deployed on top of this hardware, we are using OpenShift, which is built on top of Kubernetes. The latter is widely known software to facilitate deployment of containerized applications. OpenShift adds additional layer of security and usability. Here you can see service catalog, which shows a wide range of possibility of applications easily deployed within the selected hardware. And it's quite easy to configure and change, modify, deploy. Within the project NVIDIA, there are located our demonstrations. I will come back here later on when I show you the application. So let's get back to the application itself. This is the demonstration application, actually a client of the demonstration. There is also a web server performing the image classification. It is deployed within the OpenShift. It is performing this image classification based on inference on residual neural network. For this purpose, we have utilized pre-learned network delivered with TensorFlow, and our development was performed with the configuration of PaaS, platform as a service, on our hardware, as well as optimization of the deployment, so containerization of the application, as well as optimization for the specific hardware. We are able to deploy the classification process on different computational architectures, including multiple CPUs and GPUs. Let's take a look a little bit at what's going on. So right now we are performing the classification on multi-core CPUs. The images that are highlighted are images that are actually already classified. When we double click on the image, you can see the terms that were most significant or most probable for that particular image. So this is sports car. Let's have another try. This is bicycle. slightly misclassified as bicycle for 2. Warplane, military plane, bastard. Okay, so we can see that the classification is quite alright. Here on the bottom left we can see the image classification performance and the efficiency in the context of the usage of power. Let's get back to our monitoring service. You have the same information here. This is the power utilization of the whole setup, performance, and the efficiency, energy efficiency. This is GPU, which we are going to deploy right now. GPU demonstration. Okay, I'm shutting down. I have to just change the configuration, and you will be able to see that I'm not lying. So first of all, I need to change the host name for the GPU version and some metrics that are fetched, and also, what is very important, I need to enlarge the number of threads on the client side in order to send enough images to be able to fed the GPU properly, to utilize its whole potential. And I'm running the application, which, as you can see, is written in Python. Okay, so we see that the performance is actually much higher right now. Instead of 2-3 images, we are performing right now above 100 images per second, which is quite good in my opinion. Also, the efficiency of energy efficiency of the application is much higher right now. You can see here the V100 is utilized, the power consumption of the V100, but also the Xeon E and Tesla V100, the server itself is also consuming some additional energy because it has to deploy the images, the classification process on the GPU. Okay, let's get back to the OpenShift console. Right now I'm going to the deployment. I can see that there is one replica which is active on the second deployment. Here I have some additional information. I can see the pods that are running right now. Pod is the smallest computational unit of OpenShift and Kubernetes. And as I said to you, we're running on Xeon E with V100, which is indicated here. Now I'm going back, and what can I do? I can increase the number of pods with a simple click. Right now OpenShift is doing two things for me. He's deploying a second container on a second node that is able to perform the same operations. Secondly, it's load balancing the traffic between two containers and gives me the possibility to take advantage of both containers and the calculations performed of both containers. Okay, so let's now see first the usage. As we can see, the number of processed images has doubled right now. The power consumption is much higher. The cloud efficiency is slightly lower. There are multiple possibilities of that behavior. I think it's not part of this demonstration to discuss them. But generally, OpenShift right now is shifting all the traffic between two of the running containers. One with the Xeon E P40 and second with the Xeon E V100. Okay, just a quick glimpse on the application itself. We have a slight indications considering the used technology, which is Python, and Python is unable to achieve performance of 2 GPUs, of feeding two GPUs, but we believe it's a good proof of concept of the demonstration of the cloud appliance itself, and thus it's sufficient. So for the very high performance computations, Python probably is not the best solution and choice. Okay, just a quick summary. We have showed the cloud appliance and the demonstration, which has been developed within the M2DC project. It has been visualized in our PSNC monitoring system. We are able to deploy containerized application that use computational accelerators within the OpenShift. It gives us great flexibility and ease of deployment of the application and development and deployment. Thank you for watching.